There we go.
Yeah, we are.
Okay.
Okay. So, me and Haley already did part 2. Have you?
Yeah.
Okay, sweet. So we're good to go on the quiz?
Yep.
Sweet, let's get this over with.
All right. Let's open it up here. I
Is it
just got
short one
home,
this
so
week? Oh, it's short. We have
Let's
11
see.
questions.
Mine's 13.
Well, I mean, if
Oh,
you get
with
rid
the
of
2. Got it.
I mean, those don't really count, do they?
Not really.
Exactly.
all right. One sec.
Okay.
Okay. There we go.
Okay. So, once you're on 3, let us know.
Yep, I'm there.
Sweet. Alright. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. The blood types and the proportions given in the table above define a probability distribution. True or false?
That's not a distribution, right? Because wouldn't distribution have the 2 numbers?
I think so.
What do you mean?
Oh, never mind. I'm thinking about something completely different. I was just doing microbiology homework, and you've got, like, the first distribution, and then you've got the second distribution of, like, viral bacteria. Sorry, that's not even the right thing at all. Okay, never mind. Woo, this is getting rough.
Okay. Okay, it's the probability distribution, right? It's like, this is the probability that a person in the United States has this type of blood.
Yeah.
Okay, so it's true then.
Yeah, I think it would be true. That makes sense.
Okay. So, what is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places. Wouldn't it be 0.45?
Yeah.
What is the probability that a randomly selected person will not have type O? Would be-
0.55.
Yeah.
Yeah,
Should
and
we put 0 first? Like 0.55?
that's what I'm doing.
Yeah, I was too.
And for the probability distributions, all it is it has to have the 3 rules, like the 3 rules of probability. Like it has to be between 0 and 1.
Oh, yeah, and
It
then
has
the
to-
list the outcomes.
Yeah, it has to add up to 1,
Okay.
Which it does.
which it does.
Okay, good.
So
My brain isn't on a computer right now.
Well, you have a fever, so it's okay.
Yeah, you guys, my brain is boiling.
sorry about that.
It's okay. Somebody want to read 6? Because
I'll-
obviously I'm not.
I'll read 6. It
Okay.
says, Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. Interesting. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round answer to 3 decimal places.
1 divided by 7 is
Yeah.
0.143.
That poor dog.
I know.
All day.
0.143. Okay.
All right.
Number 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? There is little evidence that dogs can detect bladder cancer. This provides strong evidence that dogs can detect bladder cancer.
I feel like 22 times out of 54 isn't strong evidence.
It's 50% of the time, really. I mean,
What was
And-
the classification for strong and
There-
weak?
Well, there's 7 different dishes, and the fact that they got it 50% of the time, or 40% of the time, almost about. Let me see what it says.
okay.
I think that would be pretty strong evidence.
I feel like
But-
it would be a strong correlation.
Yeah.
I
Okay.
think.
But let me see if there's anything else it says online about that.
Yeah.
Do you want us to move on while you look that up, or do you want us to wait?
Yeah. Yeah, you can.
Okay. M&Ms are small chocolate candies. Thank you for that. The M&M website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Round your answer to 2 decimal points.
0.13. Right?
Are we taking the green totally out, or do we have to like figure out what the green is? What's our situation?
Yeah,
on
I'd figure
green?
out figure out what the green is first.
Okay. Okay.
It'd be 0.16.
Okay, yeah. So I just got.
So that number 9 would be 0.16. And then 8 would be 0.13.
Wait. What?
Okay, so
Right?
if you Okay, so if you add up all the brown, yellow, red, blue, and orange, and then subtract it by 1, you get 0.16, so 0.16. And then
Yeah.
if you take, if you just do like 0.13 divided by 1. Oh wait, no. Do you do 1 divided by 0.13 or 0.13 divided by 1?
For what?
For the red colored candy. Sorry, I should have specified.
No, you would just take the proportion of the red.
Yeah, so 8 is
Out of-
just
out of
0.13. 9 is 0.16. And then the number 10 would be 1
10 would be
minus
0.84. Yeah, it'd be 1 minus 0.16, so it would be 0.84.
Yeah.
Okay.
Okay.
Does that make sense?
Uh-huh.
Yeah, no, I thought you guys jumped ahead, and I was like, 10 is definitely not 0.13. So that's why I was like, where are you guys at right now?
All right. The ACT scores of a student admitted to a medium-sized public university in the western United States were taken from capex.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
It would be the mean, right? Or is it the median?
I think this one's the median, right?
I think it is median, so it'd be 24.
I think.
The mean is when you add all of them up, but the median is just seeing what your observations are.
Yeah. I guess that would make sense. I'm just wondering if it's a trick question.
Yeah, that would be the worst.
Wouldn't it be? But it falls between the minimum and the maximum, which is the median kind of thing.
Yeah.
So,
I think it would be 24
I believe so too.
because it's a 50th percentile,
Which is the median.
which is a median.
All right.
So that makes sense.
12. Based on the information on the table above, the top 25% of the students scored above what number? 27.
Yeah. So that'd be the 75th percentile.
Yeah. Which is your Q3.
Mm-hmm. All right, number 13. Which of the following statements is not one of the three rules of probability?
That would be C, right?
I think C's one of them.
Yeah, it is.
Yeah, that's rule 3.
Is it? Which one is it? Am I missing? Because
It'd be the last one.
last one?
The probability is a number between 0 and 1. Oh,
If
I
the
guess
probability is high, then the
Okay.
probability is positive. That's not one of the rules of probability.
yeah, our numbers
It has
are
a right.
off.
Yeah.
So it's C?
It's the
just
last one.
the really long one that ends in negative.
Okay, that's C for me. Okay.
Yeah, that's number
Yeah.
one for
If
me.
if the probability is high, then the probability is positive.
Yep, that's definitely not the one. Okay.
Okay.
Cool.
All right.
Okay, who
With
wants
the
to go
one-
first? Oh,
Well, with the one with number 7, in a combined total of 54 trials, the docs correctly identified the specimen from the cancer patient 22 times. So, well, just the fact that it states it is very unlikely that the dog would do this well by random chance alone. So they're basically completely discounting that it was random chance with that statement.
okay.
Mhm.
So I'm
So-
thinking because of that, it would provide strong evidence that dogs can detect bladder cancer.
That's what I think.
Okay.
Good?
So, yeah, I think also he said not to, that we won't even be able to see what we got wrong, so we should probably just do it all at once.
Did you say that?
That's dumb.
Okay.
On the video, yeah.
Stupid. Okay.
All right, on 3, 2,
Two.
1, submit.
I feel like we've just launched a rocket or something.
We have 100%!
Hey, we won. Hey, we won. Ha.
We cranked this
job,
out in like
you
10
did.
minutes too.
Congratulations.
It's 8:10, so you've got a half an hour before you gotta be anywhere.
Woot woot.
Congratulations, everybody.
All right. Did we need to do anything else? Are we good?
Nope, just record the group meeting and post it to the link,
As always.
and that's it.
Okay. See you Thursday.
Awesome.
Good work, team. Yeah, see you Thursday.
Bye.
Bye.